Day 13, page 197, problem 52. We have one of these mobiles that sometimes you see above baby cribs and other places. We had one like this last year, but this one's actually a little easier than the one last year because last year the bars, the horizontal bars, had a mass, weight. And in this case, it's assumed that the bars don't have any weight. Nothing is said about that, so we're assuming they have negligible weight. What you want to do with this problem, it says the star weighs 10 newtons. So we're going to start with the lower bar. Just draw the free body diagram. Rotational equilibrium here. The net torque is 0. So if you draw that bar, you have 10 newtons here. And the triangle unknown, let's call that, well, I'll call it F sub 1. It's really a weight. Doesn't really matter. It's a force. Weight's a force. And then we have T sub 1. So this is kind of like the opposite of the problem we just did. What I would do, we know all the distances. I would pick a point, arbitrary point. Well, it would make sense to even pick this point right here. Call that point A. Calculate the torque with reference to point A. Or the right-hand side, but I would not have picked the spot where the 10 Newton star is, because then you're getting rid of some known information. But right now, with reference to point A, T1 generates no torque. So essentially, it's just, once again, generically, we could say the clockwise torque equals the counterclockwise torque. The clockwise torque with reference to point A is F1, unknown. F1, F sub 1, times its distance from that point. This one's pretty easy. You could have done it without the calculation. That's 20 centimeters equals force 2, the 10 newtons, times its distance, 40 centimeters, twice as far away. So F1 has to be twice as big. It's going to be 20 newtons. If you do the math there, that's F sub 1. Once you have F sub 1, you just repeat the whole process for that top bar. Draw a very similar diagram and do the calculation just like this. Oh, one thing you should also remember is that T1 then is the sum of F1, which is 20 and 10. So T sub 1, the tension in that little piece of segment of rope there is 30 newtons, which is the weight hanging on to the end of that upper bar.